Chapter 2, question 94. Determine the x and y axis intercepts of the line of action. So what was the line of actions? So for example, for this force, the line of action is this line. This line, okay? The intercepts of the line of action of the resultant of the three loads applied to the gear set. So the first thing is we need to find the x component and y component, each of these forces, and then we need to add them up, and then we need to find the moment of the each components about the point A or at point A, and let us do that, and I will tell you the last step later. So the total force, let us go one by one. So the x component for this one will be 1.5 kilonewton sine 20, and it will be in this way. Let's draw the, it will be in this way. It will be in this way if you project it, okay? And also for this one, again, it will be in the left side. But for this one, it will be in this way, the x component, okay? And for the y component, this, it will look like this, and this one look like this, which is negative again, and this one will be positive, okay? So let's go one by one. 1.5 kilo sine 20, and it is negative. This one is 2.4 cos 20, and it is positive. We put plus here. And for this one, 3.6 kilo cos 20 negative, so we put negative here. Now for the y components, negative, because it is negative, 1.5 cos 20, this one's, and for this one, 2.4 sine, for this one it will be 2.4 sine 20 and negative again, and the last one, 3.6 kilo sine 20, and it's positive. So, and then you will add them up, add these three and add these three, and remember to put the I and J, and ignore this line. I will explain about this line. Now the moment of O, about O, this one is passing through this point. I want to find the moment of each force about O. So the moment of this force is 0. This force, this component, the y component of this force is 0, and the y component of this force is also 0. So what about this ones? The moment arm for this one is the radius of the green gear, which is 120 millimeter, which is 0.12. So 0.12 is the moment arm, and 1.5 cos 20, and this is the amount. And is it negative or positive? It is clockwise, so it is negative. We always put for counterclockwise positive. What about this ones? Again, this is clockwise. And what about this one? Again, this is clockwise. So how much is the moment arm for these ones? 200, because this one, the radius is 120, this one is 200, and this one is 300. For the orange one, the color is orange, I think, yeah? The radius is 200. So we just put 0.2, because we have to put it in the SI unit, 0.2 meter times the x component, and it is negative. And for this ones, again, the x component times the 0.3 and negative. This will be the amount of the moment at the point O. So remember, we find the resultant force and the equivalent moment of all of the components at the point O. So this F is the resultant force that we have already, it should be in boldface because it is a vector, okay? So now you need to put the F here exactly and assume that R is AI plus BJ. Okay, now assume that this is your resultant force and this is a line of actions. So the R can be any vector, remember. R can be any vector that start from O to here. For example, this ones. This can be R. AI plus BJ. Okay, so assume that R is this ones. Assume that this is the first R, which is AI. From here to here is A, okay? Then if you put AI cross F, it will give you the A. And if you consider this as R, well, as I said, you can consider R as any vector that is starting from O, and the head should be on the line of actions. Then if it is here, you can find the B, okay? So, but in general, we have to assume that it is on positive directions, and then it will be, the answer will be negative. We can find it out, but anyway. So, I mean, this is the general idea. So you will always put AI plus BJ, and then for this one, B is 0, for this one is A is 0. Okay, and then you find the A and B with this equation, which is equal to this one.